Dear students, let us start the discussion of the role of nanotechnology in drug delivery. Okay, mm, you already know that various types of nano-sized drug delivery systems like liposomes, niosomes, nanoparticles, nanoemulsions, nanosuspensions, etc. and etc. All these are the examples for nanotechnology based drug delivery systems for uh, for targeting the drug in required quantities for the required period of time it to the specific sites inside the body, mainly to avail mainly to overcome the unnecessary effects of these drugs onto the other parts of the body, and to cure the disease or disorder, okay, with less side effects. So here the application of nanotechnology in the field of medicine will give us a separate field of medicine that is called as nanomedicine. Okay, all the drug delivery systems which I quoted as examples just now, okay, can be called as nanomedicines. Can be called as nanomedicines. The approaches to nanomedicine starts right from the medical use of nanomaterials to nanoelectronic biosensors and for future applications of molecular nanotechnology. Okay, nothing but application of nanotechnology in the field of medicine starts from the use of nanomaterials for preparing medicines. Okay, till to the levels so for developing nanoelectronic biosensors as well as for studying the applications of nanotechnology, okay, in in at molecular level, application of role of nanotechnology for molecular manipulations, for molecular manipulations or manipulations of the behavior of molecules or the role of molecules, okay, at nanoscale. Nanomedical approaches to drug delivery mainly includes developing nanoscale particles or molecules to improve the bioavailability of a drug. Here, the bioavailability refers to the presence of drug molecules where they are actually needed in the body and will do the most good. Drug delivery usually focuses on maximizing the bioavailability both at specific places in the body and over a period of time at these places. And this can be achieved by molecular targeting through nano-engineered devices. The new methods of delivery of nano-engineered materials that are being developed may be effective in the treatment of illnesses and diseases such as cancer. Drug delivery systems like the lipid or polymer based nanoparticles can be designed to improve the pharmaceutical as well as therapeutic properties of the drug. And one of the major impacts of nanotechnology and nanoscience is leading the development of completely new drugs with useful behavior and very less side effects. Okay, why? Because potential the drugs developed by this way can be called as nanodrugs, and the potential nanodrugs will work by very specific and understood mechanisms. Okay. Similarly, coming to the drug delivery systems, the strength of drug delivery systems is their ability to alter the pharmacokinetics and biodistribution of the drug. For example, take nano-based drug delivery systems such as nanoparticles. Nanoparticles have unusual properties which can be used to improve the drug delivery. Okay, so there are many areas where the nano enhanced drugs could make a big difference in increased oral bioavailability and reducing undesirable side effects. For example, by increasing bioavailability, the nanoparticles can increase the yield in drug development and, most importantly, may help to treat previously unbeatable diseased conditions. Okay, and finally, we can say that nanotechnology application in the field of medicine can create a new way of technology in medicine that shows its impact on the world, which is going to be very monumental. Okay, so this is about the role of nanotechnology in drug delivery, and let us move on to the nanotechnology or use or role of nanotechnology in tissue engineering. Okay, so before actually uh, going to discuss the role of nanotechnology in tissue engineering, let us know few terms. Let us know the meaning of or definition of the few terms, okay, that we are going to come across in our discussion. Okay, in our discussion of uh, nanotechnology in tissue engineering. Okay, so what is tissue engineering? First of all, what is tissue engineering? Okay, so tissue engineering is the use of a combination of cells engineering and materials methods and suitable biochemical and physicochemical factors to improve or replace biological tissues. I repeat once again, tissue engineering is the use of a combination of cells engineering and materials methods and suitable biochemical and physicochemical factors to improve or replace biological tissues. Tissue engineering involves the use of tissue scaffold for formation of new viable tissue for a medical purpose. While it was once categorized as a subfield of biomaterials having grown in the scope and importance, it can be considered as a field of its own. Okay, means once the tissue engineering was categorized as a subfield of biomaterials. Okay, and because of its because of the growth of its scope and importance, nowadays it can be considered as a separate field of its own. Okay, so this is about tissue engineering in brief. And what is mean by scaffolds? Scaffolds, SCAFFOLD, scaffolds. So scaffolds are materials that have been engineered to cause desirable cellular interactions to contribute to the formation of new functional tissues for medical purposes. I repeat once again, scaffolds are materials that have been engineered to cause desirable cellular interactions to contribute to the formation of new functional tissues for medical purposes. Cells often seeded into these structures capable of supporting three-dimensional tissue formation. Now, the next term is electrospinning. Okay. Electrospinning is a fiber production method which uses electric force to draw changed threads of polymer solutions or polymer melts up to fiber diameters in the order of some 100 nanometers. I repeat once again, electrospinning is a fiber production method which uses electric force to draw the charged threads of polymer solutions or polymer melts up to a fiber diameter in order in the order of which is in the order of some hundreds of nanometers. Okay, this process does not require the use of coagulation chemistry or high temperature to produce solid threads from the solution. Okay, this is an important point. And coming to the next term, this is okay, nano composite. What is meant by nano composite? Nanocomposite is a multi-phase solid material where one of these phases has one, two, or three dimensions of less than 100 nanometer, or structures having nanoscale repeat distances between the different phases that make up the material. I repeat once again. Nanocomposite is a multi-phased material where one of these phases has either one or two or three dimensions of less than 100 nanometer, or nanocomposites are the structures having nanoscale repeat distances between the different phases that make up this material or that make up this composite. Okay, so these are the few terms that are that we come across in our discussion of nanotechnology in tissue engineering. Okay, so coming to the actual discussion, there are various kinds of materials that can be electrospun into nanofiber structures which have promising applications in tissue engineering. The research of nanobiosystem is a priority to develop medical devices that once implanted will replace or enhance tissue function to impair diseases, injuries, or age with age with special reference to tissue engineering. I repeat once again, the research of nanobiosystem is a priority to develop medical devices that once implanted will replace or enhance tissue function to impair diseases, injuries, or age with special reference to tissue engineering. Tissue engineering scaffold with unique functional properties in a wide variety of applications, especially focused on the collagen based electrospun nanomaterials with variable applications. I repeat once again, tissue engineering scaffold with unique functional properties in a wide variety of applications which are especially focused on the collagen based electrospun nanomaterials with variable applications. Fabrication of biodegradable polyester nanocomposites by electrospinning for tissue engineering reviewed several biodegradable polyester based nanocomposites for tissue engineering applications. Depending upon the type of tissue, the design process can involve a variety of disciplines or sciences, including mechanical engineering, molecular biology, physiology, medicine, polymer chemistry, and nanotechnology. And tissue engineering involves both engineering and life sciences towards fundamental understanding and development of biological substitutes to restore, maintain, and improve tissue functions. Biomaterial devices that are created by seeding scaffold with cells at the nanoscale have certain properties to solve some medical challenges and caters to the needs in the area of nanomedical research. Okay, I repeat once again. Biomaterial devices which are created by seeding scaffold with cells at the nanoscale, which have some properties to solve medical challenges and caters the need of or caters some needs in the area of nanomedical research. Nanomaterials compensate for limitations of scaffold. Okay, and it can also increase the cell viability, promote adhesion, control of growth factors and cytokines, and even physically shape the biomaterials and cells to create a desired tissue structure. Okay, I repeat once again. The nanomaterials can also increase the cell viability, can promote adhesion, can control the growth factors and cytokines, and even physically shape some biomaterials and cells to create a desired tissue structure. Okay, so this is about the role of nanotechnology in tissue engineering. Okay, and let us continue our discussion with other applications in the next video. Thank you.